So your P1 lesson goes over real numbers, so different types of numbers. It also will go over comparing numbers, ordering numbers, absolute value, and different expressions. So if we look at what real numbers are pretty much any number. Any everyday number you have as real numbers. Within your real numbers, you have different subsets, which means there's different types of real numbers. You could have integers, you can have whole numbers, you can have irrational numbers, you can have rational numbers. For your rational and irrational numbers, your rational numbers are any number that you can represent as a fraction, so as a ratio. Your irrational numbers are numbers like pi, or like the square root of 2, square root of 3. Any square root that you cannot simplify would be an irrational number. Your repeating decimals are rational, so keep that in mind while you're looking at these. When you're also looking at numbers, the set of natural numbers is anything from 1 to infinity that you're working with. If you realize 0 is not included in that. 0 is a whole number, but it's not a natural number. 0 is also neither positive nor negative. So try to keep that in mind while we're going over these two. Your integers can be any positive or negative number as long as it does not have a fraction or a decimal attached to it. Okay, so integers, positive or negative, no fraction, no decimal. Your whole numbers, as you can see there, are the same as your integers, but they're only the positive numbers and 0. So no negative numbers are included in your whole numbers. So again, your rational numbers can be represented as a fraction. So like with 1/3, it's the same exact thing as 0.3 repeating. You can still represent that as a fraction, so that's a rational number. Something like 1/8, which is 0.25 as well. Again, that's a rational number. For something like 1.126 with your bar notation, that bar notation is the line that's above the 126, which means it constantly repeats, it can still be represented as a fraction. So it's still a rational number. Okay. This page just gives you different examples for irrational numbers like the square root of 2 and pi. The square root of 2 is 1.414213. It continues to go on for forever. It does not have any repetition that happens with it, which is why we do not use a bar notation on it. And there's no pattern either. So with that, it is an irrational number. So anytime you have a number underneath that radical that you cannot simplify, so like the square root of 9, that's a rational number because it simplifies to be 3. However, the square root of 10, nothing times itself is 10, so that's an irrational number. Again, within your numbers, your real numbers, you have different subsets. And this little map that's on the bottom just tells you the different types of numbers that you have. So within your two sets of numbers, you have either rational or irrational. You'll realize that if it branches off to the irrational, it cannot be classified as any other type of number. However, if it branches off to a rational number, it can be either an integer or a whole number. So with that, you have to look, is it positive or is it negative? Does it have a fraction or decimal attached to it? If it has a fraction or a decimal attached to it, it stops at being a rational number. It does not classify as anything else. However, if it does not have a fraction or a decimal attached to it, it could be either an integer or a whole number as well. In order for a number to be a whole number, it also has to be an integer. For here, we're looking at a number line. Your number line that you see here, you either have negative numbers or positive numbers. Your origin is always at 0. So it literally cuts that number line in half. Now, why are you seeing this? Because you're going to use it when you work with absolute value. We're not going to get to that till later on, but again, you're going to see it again when you work with absolute value. So your non-negative numbers here are to the left of 0 on your number line. Your positive numbers are on the right. Anytime you plot a point on your number line, it's called a coordinate. Just like you do when you work with a coordinate plane. A point on the coordinate plane is called a coordinate. Same thing with your number line. With your numbers, when you order them, you're going to be ordering them from either least to greatest or greatest to least. Use a number line to help you if you need it. With this, we're going to move into inequalities. If you remember from when you were like in elementary school, the alligator eats the bigger number, same thing. The only difference now is we are going to be plotting them or graphing them on a number line. When we graph inequalities on a number line, we use either closed circles or open circles, parentheses, or brackets. If you are working with less than or greater than, I'm literally looking right underneath that box that has that highlighted section. If you have a less than or greater than sign, you're going to have an open circle. If it's greater than or equal to, less than or equal to, so it has the line underneath the sign, it's going to be a closed circle. We are also going to work with something called interval notation. Interval notation is just another way of representing an inequality. If that inequality does not have a line underneath it, it's going to be an open circle, and we're going to use parentheses. If the inequality does have a line underneath it, we're going to use a closed circle, and we're going to use brackets. Okay. For our first example, we are describing or graphing the subset of real numbers that the inequality represents. I'm going to do this two ways with you. I'm going to represent the inequality using interval notation, and I'm also going to be graphing it. I will graph before I do the interval notation. If we graph example A, which is x is less than or equal to 2 on our number line, we would find the 2. Thank you. Because the line is underneath that inequality, we're going to include that 2 and put a closed circle there. All right, so on our number line, we find the 2. We put our closed circle on the 2. I don't need to see any other number on that number line. The 2 is enough. Okay. From here, we want to look at our inequality. As long as our variable comes first in the inequality, our inequality sign will tell us which way to draw our line. So if you look at this inequality, it points to the left. Our line will also run to the left. So either you can do it right on top, or if you want to pull it up and go to the left, you can do that too. Okay. So from here, that's the graph of it. In order to write it in interval notation, couple things. If you're working with negative infinity or positive infinity, you're going to use parentheses on that specific number. Then depending on what the number is that you're given, if the inequality has a line underneath it, you'll use a bracket. If the inequality does not, you'll use parentheses. The parentheses means that it does not necessarily include. The bracket means that it definitely includes that number. Okay, so to write the interval notation of x is less than or equal to 2, look at your number line and look at the line that you drew. Your line goes to negative infinity, so the lowest number that is going to be represented by that line that you drew is negative infinity. After we write down our negative infinity, we're going to write down the number that we're working with. That number that we're working with is 2, so we'll put that down. On this one, we're going to put the parentheses on that negative infinity, and then that 2 is going to get a bracket on it because it includes that 2. For Example B, you have x is greater than -1. So on our number line, you're going to find that -1. This one's going to get an open circle, so it's not also equal to. Since your variable comes first, your line goes the same way that your sign is pointed. That inequality is pointed to the right, so your line runs to the right as well. For your interval notation, you're going from -1 up to positive infinity. That -1 and that positive infinity both get the parentheses on it. For something like example C, you have -2 is less than or equal to x, which is less than 3. You want for this to separate this into two inequalities. So you're going to have x and -2 as well as x and 3. Easy, that x and that 3, your sign's open to the 3, it stays open to the 3. However, the -2 and the x, that sign is open to x, so you want it staying open to x. So when you go to graph this on your number line, you're going to find -2, you're going to find positive 3. On that -2, your sign is also equal to, so you want the closed circle. On the 3, you want the open circle since it's not also equal to. Your line is going to connect these two circles. Yes, they would bypass both of those numbers, but you only want what's included on both, so what overlaps on the two. So for your interval notation for this one, your lowest number is -2, your highest is 3. 3 gets the parentheses, -2 gets the bracket since it's including. For example D, we have x is less than -3 or x is greater than 5. For this one, we're going to have two parts of it on our number line. So we would find -3, we would find 5. Both of these are going to get an open circle since we don't have that line underneath the inequality. For the -3, since x comes first, our sign points to the left, our line's going to run to the left. With the 5, since x comes first, our sign points to the right, our line will run to the right as well. To give the interval notation for this, we're going from -infinity up to -3, not including the 3, so we put the parentheses on it, with a union of 5 to positive infinity. Again, not including the 5, so the parentheses will go on that 5 as well. Then for E, we have -17 is less than x, which is less than or equal to 12. We're going to separate this into two inequalities. One that has x and -17, where our sign is open to x, it stays open to x, and the other x is less than or equal to 12. So on our number line, we find the -17, we find the 12. -17 is going to get an open circle. Then the 12 gets a closed circle. Your signs or your lines would overlap one another, so that these two would just be right where they overlap. So ultimately, you're just going from -17 to 12, open on 17, closed on 12, line connects the two. So the interval notation for this would be from -17 up to 12, including the 12. From here, we just look at the different types of graphs with the interval notation and the inequality that they belong to. You also have some examples here as well, making sure you realize that your infinity and your -infinity both get those parentheses. Anything that is also equal to the number will get a bracket, but everything else will get parentheses. We are going to skip over the word form of these, and I want you to actually look at graphing the interval. So in example 1, we have the numbers between -1 and 0. So if we were to graph this on our number line, we would find -1 and 0. Now both of these have parentheses on it, so both of them would have open circles. The interval notation of this is given to you. So if we looked at the line for this, it would literally just be between these two, so they would connect each other, which means that -1 is less than x, which is less than 0 for that inequality. For example B, we have the numbers between 2 and infinity, so anything greater than or equal to 2, because that bracket is on that 2. So on our number line, we would find the 2, closed circle on that 2, and it would go to infinity. So that would just be x is greater than or equal to 2. For something like example C, where you have from -infinity to 0 on your number line, you would find 0. Open circle goes on that 0, and your line goes to the left to -infinity. So then this one would just be x is less than 0. And then lastly for D, on your number line, you would find the 15, close circle on the 15, and this one goes to positive infinity, so our line would go to the right, which just means x is greater than or equal to 15. We're now going to go over absolute value. Absolute value is literally just the distance between that number and 0 on a number line. It's always going to be positive, always. Okay, so if you look at something and it asks you for like the absolute value of -1, you're just making that a positive 1, so it was 1. If it asks you for the absolute value of 36, it's still just positive 36. It's literally the amount of spaces from 0 and that number on a number line. So it's always going to be positive. If we look at this example, it tells you to evaluate the absolute value of x over x for a is greater than 0 and b is less than 0. For a number greater than 0. Pick a number that's greater than 0. 2. So if we use 2 for this, plug this in for x, wherever you see the x. So if we do that, we're going to have the absolute value of 2 over 2. What's the absolute value of 2? It's just 2, so that's 2 over 2, which is equal to 1. For b, it tells you that x is less than 0. Pick a number less than 0. -2, okay? So we're going to have the absolute value of -2 over -2. What's the absolute value of -2? 2. And 2 over -2 is equal to -1. So what do we see with these two? If you're taking the absolute value of a number and it's over itself, if that number is positive, it's going to stay positive. If that number is negative, your answer is going to be negative. That's if there's no other operation happening here. Okay? For your properties of absolute value, if you have the absolute value of something and it's just a single term, it's going to be something greater than 0. It can also be equal to 0. If you have the absolute value of a single term and that single term is negative, it's also going to be greater than or equal to 0. Okay? For the absolute value of two terms being multiplied, you can separate those to where it's the absolute value of one term times the absolute value of another term. For a fraction, you can take the absolute value of your top over the absolute value of your bottom. Thank you. As long as your bottom is not equal to 0. Remember, you might want to take notes on this, write something down about this. You cannot have 0 in the denominator. 0 in the denominator, so something over 0 is undefined. Okay? So you cannot have 0 in your denominator. For our next examples, we're finding the absolute value of each of these. For A, we have the absolute value of -13. Make sure it's positive. That would just be positive 13. For B, we're finding the absolute value of 4. You're just keeping that positive, so that's positive 4. For C, however, you have the absolute value of 2 minus 17. Remember, this is the same thing as saying 2 plus -17 on the inside. Your 17 is greater than 2. The sign in front of it is negative, so you're going to keep the negative and subtract the 2. So that's the absolute value of -15, which is just positive 15. For D, you have the absolute value of -8 plus x. Let's use -5 for x. If you plug in that -5 for x, you're going to have the absolute value of negative 8 plus negative 5. Negative 8 plus negative 5, they're the same sign, so we're going to keep the sign and add the numbers. That gives us the absolute value of negative 13, which is just positive 13. For our next section, we're going to look at algebraic expressions and your basic rules of algebra. You have different types of terms when you're working with these algebraic expressions. The reason why they're called algebraic expressions is because you have letters involved in this now. So those letters are your variable. So in this case, you have x squared minus 5x plus 8. That x squared is a term. The negative 5x is a term. The 8 is a term. Your variable terms are the ones that x is included in. So that x squared and that negative 5x are variable terms. The one that does not have a variable on it is called a constant. So a number by itself that's not attached to any letter is called a constant. Those variable terms also have a coefficient in them. Your coefficient is the number that's in front of the letter. In something like x squared, you don't have a number in front of that x squared, so it's understood that it's a 1. For like the 5x or the negative 5x, that negative 5 is your coefficient. When you evaluate or simplify these algebraic expressions, you are going to use the sign in front of the number to combine like terms. Like terms have to have the same variable and the same power. So if you're given an x squared and a 3x squared, those are like terms since they have the same variable and the same power. With our next example, we're going to be given an algebraic expression and what that variable is equal to. We're going to substitute in that value for the variable and simplify. So in example A, we're given negative 3x plus 5 where x is equal to 3. Plug it in, simplify. So this is going to give us negative 3 times 3 plus 5. Remember your order of operations here. Parentheses, exponents, multiplication or division from left to right, addition or subtraction from left to right. So you will multiply before you add in this one. You're going to do the negative 3 times 3, which gives you negative 9 plus 5. You have two signs here that are different. So keep the sign in front of the bigger number, which is negative, and subtract the 2. 9 minus 5 is 4, so that gives us negative 4 for our solution. For example B, we have 3x squared plus 2x minus 1, where x is equal to negative 1. So anywhere we see an x, we're going to plug in that negative 1. So it's going to give us 3 times negative 1 squared plus 2 times negative 1 minus 1. If you see here, I make sure those parentheses are around the negative 1. That tells me that I am multiplying. So for the 3 times negative 1 squared, you're going to do the negative 1 squared first, which is going to give you negative 1 times negative 1, which is positive 1. From here, you're going to multiply. You have 3 times 1, which is 3. 2 times negative 1 is negative 2. Now we'll just subtract. The 3 minus 2 is 1, and 1 minus 1 is 0. For example C, we have 2x over x plus 1, where x is equal to negative 3. So we're going to plug in negative 3 anywhere we see an x. So that's going to be 2 times negative 3 over negative 3 plus 1. Multiply your 2 times negative 3 first. 2 times negative 3 is negative 6 over negative 3 plus 1. Simplify your addition. That gives you negative 6 over negative 2, which simplifies to be 3. For our next part, this just tells you that you're working with different operations dealing with these real numbers. So you're going to be multiplying, subtracting, or multiplying, dividing, adding, and subtracting. Okay. with these, again, it tells you that your variable, your bottom number, your denominator of your fraction cannot equal 0. So keep that in mind. If you are if you are dividing fractions, you are going to work with something called your multiplicative inverse, which just means the reciprocal of that fraction. So when you divide fractions, dividing fractions, if you have something like 3 over 4 divided by 1 over 2, you're going to keep, change, flip. Keep the first, change to multiplication, flip the second. When you flip the second fraction, you are taking the multiplicative inverse, or the reciprocal of that fraction. So it just becomes 3 over 4 times 2 over 1. Then you would multiply straight across like you normally would with fractions. If your fractions can be simplified at this point, you can do that too by cross-simplifying. So in this case, your 4 and your 2 are both divisible by 2. So your 2 would turn into 1, your 4 would turn into 2, and then you would multiply straight across. So that would just be 3 over 2. Okay, this is something you should be aware of from like middle school. Just a little bit of a review. Okay. If we look at different properties, I'm not going to worry about this. Just know that your addition and your multiplication are interchangeable. So like you can, if it's giving you something like 3 times 4 times 5, you can do 3 times 5 and then multiply the 4 by that. Same thing with 3 plus 4 plus 5. You can add the 3 and the 5 and then add the 4. So the order in which you multiply or you add can be changed around. You cannot do that with subtraction or division. Okay. These are just your properties of like multiplying, dividing with negatives and everything. Remember, when you're multiplying or dividing negatives, a negative times a negative is a positive times a negative, or a negative times a positive is a negative. So same signs, positive, different signs, negative. Properties of 0. We're not going to worry too much about that. Just know that anytime something is multiplied by 0, you're going to get 0. Same thing. These are all your fraction operations, okay? So when you multiply fractions, subtract fractions, add fractions, divide fractions, that's all here for you as well. All right, so in your next example, we're asked to find equivalent fractions, divide fractions, and then simplify those expressions on the bottom. For your example A, we're finding the equivalent fraction of x over 5 is equal to 3 over 3. If you're finding equivalent fractions, these two have to be equal to one another. 3 over 3 is also equal to what? 1. So this is telling you something over 5 is also going to be equal to 1. Any number over itself is equal to 1, so x is equal to 5. For example B, you're dividing 7 over x by 3 over 2. Again, we're going to keep, change, and flip. So that's going to give us 7 over x times 2 over 3. We're going to multiply straight across on this one. So 7 times 2 is 14. Over x times 3 is 3x. So it would just be 14 over 3x. For example C, we have 3 over 7 times 11 over 15. We're just multiplying here, so we can either multiply straight across and then simplify, or we can cross simplify and then multiply. I like to cross simplify first, just so that way, thank you, I'm not doing it later on. So if I cross simplify, the 3 and the 15 are both divisible by 3. So 3 would turn into 1. 3 goes into 15 5 times. So technically, I'm doing 1 times 11 over 7 times 5. The 1 times 11 gives us 11. The 7 times 5 is 35. Now, you cannot simplify this any further. If you did multiply straight across and you got 33 over whatever 7 times 15 is, you would then have to simplify that further. So I cross simplify first, so that way I don't have to simplify at the very end. For example, D, we have 4/5 times 8/9. You cannot cross simplify here. The 4 and the 9 do not share a common factor other than 1. The 5 and the 8 do not share a common factor other than 1. So you are going to multiply this straight across. You have 4 times 8, which is 32, over 5 times 9, which is 45. There is no factor of 32 and 45 that go into both of these numbers evenly. So that is your answer. For example, E, we have 3 over 7 divided by 9 over 14. Since we're dividing these two fractions, we're going to keep, change, and flip. So keep the first fraction, that stays 3 over 7. Change the division to multiplication, then flip the second fraction to be 14 over 9. Ask yourself if you can cross simplify. Is there a common factor between the 3 and the 9? What? 3. So 3 goes into 3 once, 3 goes into 9 3 times. Is there also a common factor that both 7 and 14 share? What is it? 2 goes into 7 all the way? 7. So 7 goes into 7 once, 7 goes into 14 twice. So that turns into 1 over 1 times 2 over 3. So if we multiply this straight across now, that gives us 2/3. And then again, because you simplified before you multiplied, you do not have to simplify at this point. For example, F, we have 5 over 11 divided by 6 over 13. So we're going to keep, change, and flip since we're dividing fractions. So this gives us 5 over 11 times 13 over 6. Can we cross simplify? The 5 and the 6 do not share a common factor other than 1. 11 and 13 do not share a common factor other than 1. So in this case, multiply straight across. The 5 times 13 is 65. The 11 times 6 is 66. So that gives us 65 over 66. For our last part, prime numbers, which are something like 1, 2, 3, 5, 7, 11, those are all prime because they only have factors of 1 in itself. We also look at prime factorization. So like if we looked at 24, for example, and we were to find the prime factorization of 24, we can say that 4 times 6 is 24. The 4 is 2 times 2, and the 6 is 2 times 3. So we could write that as 2 times 2 times 2 times 3, or if it asked us in exponential form, we have 3 2's, so that would be 2 cubed times 3. So you could give either of those depending on what they ask for. If it's just the prime factorization, you can give the first one. If it asks you for the prime factorization using exponential form, that would be the 2 cubed times 3. And then next we have the prime factorization of 74. 74 is 2 times 37. 37 is a prime number, so that just means that it's 2 times 37 is the prime factorization of 74.